In this presentation, we're covering the problem of design bias, which is part of the series in machine learning ethics when we're talking about bias. And we'll do our familiar 6-question framework to work through this issue. Okay, what is the problem? So, as is clear to most people, and especially if you watched the other videos in the series, a model can become biased if it's using biased data. That's pretty obvious, but that is not the only source of algorithmic bias, right? So we can talk about data bias, but I think the topic of algorithmic bias can remain separate. One reason is because models can become biased from more than just the data that they're using. Also, data bias, you can care about that for other reasons than just that it's going to poison the model. Okay, so bias in this sense can arise from the way the model is designed, and that includes a failure to anticipate how it's going to be misused. I'll talk about that more later. And a lot of what I say here, I'm assuming that the bias in design is unintentional, but that's not actually always the case. I'll say more about that also. Okay, as the field of AI ethics was very new in 2016, around then, an author and thought leader named Cathy O'Neil published a book called Weapons of Math Destruction. And one of my favorite quotes from that book is, "Models are opinions embedded in mathematics." And even though that book is almost a decade old now, the truth contained there, including this statement, has not expired. That is still absolutely true. Okay, mathematics, right? So math, 2 + 2 is 4. It's something objective. But the models, even though they're in terms of numbers, reflect the opinions, assumptions, choices of the humans who designed them, which, of course, when we're talking about choices and assumptions, we're talking about bias. It's pretty easy to imagine how bias is introduced that way. So, in a sense, the bias is kind of hiding. All right, apologies in advance for the text-heavy slides, the next few slides, but I just want to give you a sense of, this is not a complete list. I'll rattle off about 8 or 9 things here. Not a complete list, depending on the machine learning task that you're doing, depending on the machine learning architecture that you're using. There's many other things that could be included, but usually when you're outputting probabilities, you need to select a threshold, such as, things on, here's the line, and on this side of the line, they're yeses, and on this side of the line, they're no. Well, where is that line going to be? Like at what probability? 0.5, 0.6, 0.1? Someone has to decide that. The learning rate, that's also a parameter, or that needs to be set by a person, that may influence how the model learns, and you're not intentionally telling it not to do this, but it could end up favoring a majority group or something like that. Imbalanced class weights, that's more of there's a lot of best practices for that, but if the classes are imbalanced, if you have like way more yeses than nos, then the model is gonna work itself around the yeses more so than the nos. The loss function, the way that you formulate the problem, you have to be able to translate your problem in terms that the model can comprehend, so to speak. The classes have to be labeled, and usually a person has to decide how those things are going to be described or how they're going to be classified. So, for example, let's say you're trying to tell the model to recognize hate speech. Well, you have to have examples of hate speech, right? And so, one person might think that something is hate speech and another not, for example. The features that you select, right? So it's rare that all features are involved in the model. You curate a kind of a list of features, and that can change the results, alter them. We've talked about this at some length elsewhere in the problem of fairness metrics, but the models optimize for a particular metric, and that might be not the most important metric to care about. And similarly for which metrics optimized for, it can harm specific populations, and how it's evaluated once you say, hey, how did this model do? Very similar to the previous two problems. Okay, that is not a comprehensive list, but I'm just trying to give you a sense of the breadth of the design choices, and why Cathy O'Neil says that models are opinions embedded in mathematics. Like, you have to make these choices, and there's a lot of discretion involved, and you're not necessarily held accountable for those decisions. Okay, so what is familiar about this problem? So there's a really famous example from someone named Robert Moses. He was in the 20th century, really, really big in design in New York City. And one thing that he did lots of things, but one thing that he did was design bridges that you have to drive under on the way to the beachfront. Okay, and I'm pretty sure that this is an actual picture of one of his bridges, although I did not verify that, could not verify it, but it doesn't really matter. It's a low bridge, okay? So this is the kind of thing he designed. So the bridge was sufficiently low so that buses could not get through, but it was sufficiently high so that cars could get through. So the beach in that case was effectively reserved for car owners, and car owners are often wealthier, and that was especially true several decades ago. And of course, unfortunately, given the wealth disparity between races, that meant that a disproportionately white wealthy people could access the beach, and other people were effectively excluded from it. I mean, you weren't actually excluded from it. You could go to the beach, but you had to figure out how to get there via public transportation, which was far less convenient. Okay, so here's a question that you could get caught up on. Was this intentional? So there's a famous book called The Power Broker, written by somebody named Robert Caro. I confess I haven't actually read this book, but I've heard that Obama, when he was in his 20s, read this book, and it was influential for him. But Robert Caro is... I've read many summaries of the book. Robert Caro is not kind. He accuses Robert Moses of being just a racist. Like, he wakes up in the morning, thinks about how he can hurt people from other races. And so he did this all on purpose. So this is a difficult issue, because on the one hand, intentionality is important, because if someone is actual racist and is doing, racist or sexist or whateverist things on purpose, that is something that we really need to pay attention to, right? We need to make sure that they are nowhere near the levers of power and the levers of design, because they're just going to do bad things. And I don't know what Robert Moses' situation was, what was in his heart, but in another sense, intentionality can be a distraction, because what actually matters is the effects of his design, which the effects of the design were that only wealthier white people were able to access the beach. Others were effectively excluded. So that's the thing that we need to care about. I mean, I imagine it's got to be like, there's got to be some intentionality there, right? I can't imagine that no one thought of making the bridges high enough for buses. There wasn't any point in the design process where someone raised their hand and was like, hey, what about buses? But I wasn't there and was not paying attention to those debates. But, what we should think about, what I want us to take away here, is that, with all due respect to the complexities of engineering bridges, constructing machine learning models, there's a lot more moving pieces involved. So there's a lot more room for design bias and unintentional design bias, right? Again, it seems weird if you want to say like, oh, I didn't know that the bridges were too low. But think about that list that I ran through. I mean, there's so many choices that the engineers, designers of the system have to make. And it's pretty easy for me to imagine how they could make a decision that would actually change the outcome, that would bias the outcome in some way, but they didn't mean to do it. Okay, so we can kind of bracket out the intentional, unintentional conversation, with the exception of like we do want to know when it's intentional, but I'm assuming that most in the end, it doesn't matter, right? If the model is biased, that's what's important. And I'm assuming that most people don't want biased models, but again, there's just so many ways for models to become biased, even if you don't mean that for that to happen. Okay, so simply the larger the model is, the more data, the more features that we're talking about. It's just really difficult to have any kind of meaningful insight into the implications of what you're doing, like the loss rate. There sometimes you get like a little bit of feedback if the data doesn't get processed properly. You get that feedback and you got to change. But oftentimes you make these choices in the parameters and the hyperparameters of the model, and they're just you don't get feedback about, oh, you chose this parameter that influenced the outcome this way. That usually doesn't happen. So what's new because of the capabilities of digital technology? Okay, what I want to say about this is that when you're designing something, a basic design principle is that you should be thinking about what happens when someone misuses this, whether that's unintentional or intentional. Okay, and notice I said when someone misuses this, because whatever you're designing, there's basically 100% chance that someone's going to use it in a way that you didn't intend for them to use it. I don't care how simple it is. I don't care how complex it is. That's just the way. So that's always been a design principle that we want to pay attention to, right? But now that design principle is even more important, because a lot of AI systems, the people that use them are, in a sense, co-designers of the system, right? Because the way they use it actually changes how the system is. There is a famous example from a few years ago, the early days of AI, of a chatbot named Tay, and this was released by Microsoft. And this bot was on Twitter, and they released it in the morning, and by the end of the day, they had to take it off. Why is that? Because and this is an example of people intentionally misusing it, but a lot of users fed Tay these like over-the-top, horrible, racist kinds of things, and so Tay was absorbing that those inputs, and then it was changing the way that Tay would process and think, right? So by the end of the day, Tay was like denying that the Holocaust existed and this kind of stuff, and so there wasn't really an obvious way to rescue it at that point. It was just a moral failure, and so Microsoft pulled it off. So you could think of this as another source of bias, right? So you could think of that, okay, we have data bias, we have design bias, we have emergent bias, and some people classify it that way, and that's fine. I don't have any big problems. But I do think it is better, or at least it's the way I think about it, to think of emergent bias as a kind of design bias. And that's because in the design process, that's when you're supposed to be thinking about what happens, not if, but when this product is misused. Okay, obviously we're talking about fairness here. Okay, potential solutions. So the place to start is just making sure the designers of the system are sensitive to fairness concerns. This comes through just training, making people aware of like, hey, this can go wrong. This also, not a magic bullet or anything, but it sure helps a whole lot. is to make sure that the team of designers you have is diverse, and everyone's opinion has has influence. Everyone has a seat at the table. Not just that you have people on your design team, but they don't get to make decisions. So everybody is making decisions. So, there are, the term is debiasing. You can debias at the beginning. You can debias like as the model is being constructed, and you can also audit it and go back and debias it and say, okay, the model is this, but this isn't working the way we thought, and so now we're going to debias. So if you're looking for a place to start, my favorite Wikipedia page is called Fairness, in parentheses, Machine Learning. And so I would recommend starting there, and then of course, Wikipedia works, there's a bunch of great references, and so you can click on those and start reading some peer-reviewed articles and some books and stuff. So the last section of that page is on debiasing. There they call it bias mitigation strategies, same thing. And they divide it up into the pre-processing and processing and post-processing stage, as I mentioned earlier. Okay, those are some thoughts on the problem of design bias.